Yeah, quantum physics type video, Feynman. So we'll play some of this, and it sort of makes my point. It's not taken too literally, but if you take what he says literally, he says some pretty important things that need to be said, and so I'll try not to interrupt too much, but let's play some of it.
One thing, though, I must say, and that is this. We've been talking about light going through a vacuum, and then I had a rule about it's reflected by a certain amount when it goes, it has a certain shrinkage when it comes off a surface. When it goes through a medium, it gets slowed up, and so on. These, it turns out, are not really the properties of light. That have to do with the properties of matter.
Alright, so there you go. He says it again another way, so I'll keep playing it. But so he's sort of making the point that all of these interactions are dependent on interactions with something, and that something is what's making light do things. Yes, it's not the light.
You can't get reflection without having a piece of glass. It doesn't go slower unless it's in the glass. It really, as it turns out, is not going slower. It's curious, and we're going to find out exactly what it does. In order to...
Yeah, so what he's talking about there is when light goes through glass, it takes longer to get through the glass because it's interacting with all the electrons it bangs into on its way. And those electrons keep regurgitating light. And it's not perpetuating the same photon, it's perpetuating a new photon on the same course.
To explain it, we have to know what the electrons in the glass are doing and how they interact with the light.
So he's saying, to know what the light's doing, you have to know what the electrons in the glass are doing and how they're interacting with the light. Again, it's not a phenomenon of light. Quantum mechanics is a phenomenon of the structure of atoms and, more importantly, the structure of electrons.
And I'll summarize the most wonderful fact is that light never does anything, really, when you get down to it.
There you go. Light doesn't do anything, really, when you get down to it. Pretty clear. It certainly doesn't go through two slits at once.
Except to go in a vacuum from one place to the other. It's emitted by one atom or particle and absorbed by another. And it never goes and gets slowed down or gets reflected. What reflection really is the light goes down, is absorbed by something which shakes it, and that emits a new light which comes back. Reflected light is really not the same photon coming back as went in. The photon from the source went into the glass, and from the glass comes out a new photon.
There. So that's, there was some comment dispute about that with some other guy who said, it's about the light being absorbed. So clearly some light is absorbed when we see something, when we're looking at something. Part of the light got absorbed out of the white light that you would hope to start with, the red, blue, and yellow light you start with, and depending on what's absorbed, the rest comes back at you. And what comes back at you, I argued was, synthesized, was a byproduct of. But it's technically also reflected in the sense that it's not reflected like it bounces off and then comes to you. Reflection is actually absorption, but it's not retention. So there's a difference between absorbing it and keeping it, and absorbing it and readmitting it. Technical detail, I don't know if it matters too much, but it probably all matters to some extent.
This is an interesting thing that makes light in the end simpler and simpler and simpler, and what I was trying to get.
Yeah, there. So in the end, he's saying light's simple. Light isn't complicated. Light isn't multidimensional. Light isn't doing all this nonsense. The interaction between light and electrons creates the distortions in the destiny of the light. The light goes into the gravity well one way, it comes out in another direction. Just like a spaceship entering the gravity of a planet, it changes because it's now not taking the shortest route. From its perspective it is, but from its space perspective, from its perspective and number of pieces, it's now changed its direction because of that interaction. Not from its perspective, but from the universe's perspective.
That was to show how ultimately simple it is when it's only in a vacuum. And the complications of funny laws for reflection and funny laws for going through glass are really the result of the interaction of light and electrons. And that's why...
And there you go. You know, pretty direct statement. Like I said, I don't know, you can't take it... I'm not going to be unfair enough to say there. That's it. We don't have to worry about anything else he ever says. But I mean, clearly, I think I think you can put the other statements he makes in the context of when he says something like just do the math, or he's just saying, look, we don't have the model of this thing, but let's just pretend we're just going to deal with what photons are after the interaction and what the probabilities are and what the outcome is, and we're not going to worry too much about how it got there. So for the sake of the conversation, it's almost like anthropomorphizing and talking about nature building organisms, or you know, you know, to survive it became, you know, and we talk as if there's intent. You know, yeah, in physics you can talk as if light is doing something, and you're really just talking about the byproduct of its interaction with the environment. The pinball machine is doing the work. The ball is just going where the machine forces it to go.
This subject of discussing physics can't go on any further until I want to discuss matter. And the next lecture will be about matter. All right? Thank you.
So anyway, yeah, so in his next lecture he does a lot of the, you know, the Feynman diagrams from what I remember. Anyway, I haven't watched the video in a while. And so maybe I'll go through some of that, but it is kind of, that's when you get into just a lot of math and a lot of vectors and a lot of amplitude and a lot of who the fuck knows what people are talking about sometimes with this physics stuff. So, but, you know, in this, the points made here are, you know, his point was, is again that these different wavelengths of light are the same light, is the same thing, you know, with this subtle difference, but the same behavior takes place, and it only takes place at a different time because of the wavelength difference. The timing is different, and so again we're talking about let's say you know, some kind of system, and so even if we make it a circle, it doesn't really matter, but we just make it something that has periods to it, right? And then, you know, in the first half it has a half a cycle and a quarter of a cycle, you could say. And so you could argue that that creates four conditions, you know, these four segments. And that if something was coming in or approaching, that it has probabilities of interaction. If the electron's in this position, it'll be in this position, say, 1/4 of the time. And if it is in this position, it will have a 1/2 reactivity. You know, so you have two conditions. You have first the condition of what's the chance of hitting it if it's here, and what's the chance of it being here. And those two conditions can create a fourth condition, which means, yeah, you'll get to here 1/4 of the time, and half the time that'll be the thing. So then you end up with something like 1/8 of the time. You'll have a reflection or a re-emission at the proper angle of the photon. And then you could just make the same argument for each one of these segments. Like it gets past this first segment to get to this segment. What's the odds of it getting past this segment? And then what's the odds of it hitting this segment or hitting this segment? And those could be, you know, where it might hit these segments, you know, 1/3 of the time here and 1/3 of the time here, and then these end up being 1/6 of the time each or something, because they start to spread on the periphery. And so this is the nature of the probability, is calculating the depth of the interaction. How many variables are there to the interaction? with, and with the possibilities, and with the basic, what's built in basically to quantum mechanics is a sense that, you have, some sort of mechanism, that creates this, that has a basic sine wave kind of shape to it in terms of these probabilities, and that they're all kind of absolute. Like there's, like I said, this sense that they can be only these things or nothing. So they're either one of these kind of interactions, or there's no interaction. The photon is absorbed, or there's a zero reaction. So you could argue that in this mechanism, failure could be in any one of these paths can lead to a zero result by it just having that 1/2 chance of not interacting. So going through two of these things would mean that there would be only a 1/4 chance of not interacting on this path, because it's going to intersect two segments. But here, technically, it wouldn't be going through the depth of a potential for interaction. The potentials gets thinner on these outside edges, and but the odds of the interaction are still the same. So the bars, the zero spaces would remain constant, where the chance of interaction is what gets bigger. So I mean, that's just one way of explaining why you'd end up with a filtered result like that, is just the style of interaction which is dependent on whatever these variables are. And again, these variables can be decided not just by rotation, but it could be because of a vibration up and down, or it could be different circumstances different other circumstances that I'm not describing. There could be many possibilities to why this is the nature of interaction with matter, light interacting with electrons anyway. I mean, that's really the only thing they interact with. So whether the electrons are associated with matter or not, in an atom, or merely shared by atoms, maybe is another question. How free electrons are in matter is a whole other subject. So technically it would have to be an electron, so let's say all electrons are associated. They're just not associated. They're associated either hard, like in a dependent matter where they're captured, or they're associated in a manner that's more easily liberated. So, in the end, I'm going to say that matter, that energy really is just some sort of hook device, whether they're, it's an actual hook, and that things are hooked on each other. But my argument is this is the nature of how matter is working, is that there is these harder structures. They're not as ambiguous as forces, and they only look like forces in our big world, but on the small level it starts to get more structurally simple. So I would envision that if we could really model an atom, that we might find that it has a huge amount of actual mechanical structures, that however the nucleus is held together, that the nucleuses are actually hooking, holding electrons in their spin, and that those spins are, hooked by, interlocking devices, as I've described previously, and that this is the real nature of it. And then what you're really doing is, well anyway, it gets complicated. I mean, I like to get into the subject of this whole thing of, what creates critical mass, let's say, in a nuclear reaction. But that's sort of an interesting phenomenon, that you can have these pieces in the mechanism that you could break off and set free, and that when you set them free, they crash into other atoms and create more hooks, more free parts fly off. So, you set one free, and it sets two free, and those two set two free, and those two set two free. I mean, this is the nature of a nuclear reaction. Is that it just keeps multiplying the pieces that are capable of breaking atoms apart. And that's sort of an interesting, the mechanism that would be able to do that is an interesting subject. It's kind of like filling. It's like if there was something you could create, some piece of rock, and you could throw it at the earth, and it would satisfy the earth's gravity. It would plug the drain hole that's creating the gravity, the change in the space that's causing matter to fall into the earth. Then all the particles on the earth would be released, and some percentage of those particles would be able to fill the drain on other bodies capable of sustaining gravity, and then their gravity would disintegrate, and it's that kind of a mechanism. I don't know if that's a great description, but close enough. So anyway, I'll deal with some of these comments, and I'll call it a day. Comments on my last video, which I have to find, which weren't too brilliant, of course, not too helpful and all that kind of crap. So I guess we'll start at the top. I don't think there was anything rational up here. So anyway, Hoffel today, he did post a clip. I didn't find it all that useful. This Murray Gill man guy. He's not doing much for me. So if he's agreeing with me, he's not doing it in a way I can understand, which is sort of annoying. He's not too big on spooky action at a distance kind of bullshit, so that's good, but he's, he does seem comfortable with an awful lot of particles that I don't think even really exist. But anyway, I don't want to even get into that. So anyway, the lazy narcissist who I have finally blocked, he's been posting this same spam everywhere about me eating Cheez-Its, and so now somehow that means something. I mean, even if I ate roast beef, how does it change the argument for vegetarianism? If let's say I ate meat every day, and I still made videos about how it's cruel and wrong to imprison and torture and murder animals for selfish, personal, almost trivial excesses, that you can satisfy your needs without doing that. How does it change that argument? Oh, that wouldn't change it at all. And again, the number of, I have what, a box of, let's say I had 12 boxes of Cheez-Its a year. Yeah, I just don't think that's enough milk to crucify me on the hypocrite stake. So, whatever. Fuck you. You're just too stupid for words. Anyway, it's amazing lengths your mind goes to prove nothing is phantasmagorical when the realization of this century is that light defies your logic box. So, Feynman, who is, sort of by reputation is, next to Einstein almost in being one of these brilliant minds of the 20th century and all that kind of crap, 21st century, whatever, just pointed out that light isn't doing any of that crap. So, yeah. Yeah, I'm sorry. Yeah, so fuck you. So the Carla thing, this is just too convoluted a thing. I don't know if there's any point in bothering with this. The slit wasn't closed that way. I don't even know what that means. It was slid across. I described it perfectly adequately, so I don't know what that means. There was a sliding mass behind the slits. No, there was one in front of the slits. I mean, you know, but you can say behind. It doesn't, you know, there was one between the target and the slits, which is the wrong place to put it. It wasn't a mask, it was a hole. There was a sliding mask behind the slits. It did not touch the double slit wall. It had a distance of 230 UM. Well, UM is not a nanometer. Well, anyway, I think 230. I think the slits are 290. So it's almost the distance is almost as thick as the slit. So why didn't they make it even closer to be more certain to prevent any light sneaking around the barrier? Also, if your theory is were correct, then there wouldn't be this particular diffraction pattern. Of course there would be. When it's wide open, two slits are there, there would be. When the two slits are open, of course there would be. I'm not denying the creation of the pattern. I'm denying that it's created by photons going through two slits at once. But instead, the pattern when two slits were open would be the sum of the two patterns when just one slit was open. Well, again, you can't say open slits. You've got to say covered or obstructed. It still creates a barrier across which light is going to be diffracted. So it's going to be creating an imperfect experiment. But I would argue that if you use Photoshop or something, I'm really not going to take the time, and took the images of when one slit is barely open and when the other slit is barely open, and you superimpose those two images on top of each other, that you're going to come up with something that's almost 70% the same as when both slits are open, which indicates that there's an awful lot of pattern being created by single slits, by single openings. That would be the pattern you get when you lay the picture P1 positioned at 250 nanometers from the center over the picture P2, because approximately 50% of the photons that are registered went through the left slit and 50% through the other slit. Yeah, well, that's the question, right? We don't have measurements of the intensity of the light, so that would be something that would be useful to know, is that when one slit is opened, is it exactly half the number of photons that are in the two slit? And that would be just to see how much leakage there is. Instead, however, there's an interference pattern, not the sum of the two patterns. I don't know what you mean by the sum of the two patterns. You're saying there's no pattern when one slit is open, and I'm saying if you look at those images, there's a definite pattern. And if you just multiply that pattern by superimposing the other image on it, you'll see that the image is going to be highlighted. They're not going to. They're going to constructively interfere, not destructively interfere. So I just think you're wrong. I think you're misinterpreting the experimental data. And again, my argument is it's not my experiment anyway. It's not the test I would do of the two-slit experiment. It's not a great way to test it. And you're certainly not counter-arguing my point that if the interference pattern was truly an interference pattern, obviously with one slit covered, there's no possibility of an interference pattern, because now there's no distance for the interference to take place in, and without that distance, how do you explain the pattern that is obvious in one slit being open? As you definitely see the artifacts and the dead space. So you're wrong. Alright, how do you account for general spin property, quantum number? How do you explain its discrete nature? That it only has values of 1/2, 1 to 2/3, 3 seconds. That's 1 and 1/2, I guess. 0, minus, and then 1 and 1/2 again. So how do I explain why something has 3 positive values and 0? and then does the same negative. I mean, I don't know why would I have to explain that things are in different states? Yeah. With a general spin property. I'm not sure what the general spin property is. And I think all pheromones have spin. Well, I don't even know if pheromones are a real thing. Pheromones. Pheromones. Well, whatever. Pheromones. Well, whatever. Who cares? How do you explain the standard model account of all... Yeah, the standard. How do I explain the standard model? I don't wish to explain the standard model. I'm obviously saying the standard model is probably crap. And I'm saying most of the particles they're seeing through accelerators aren't real particles. They're synthesized pieces of things. And the reason why they don't last very long is because they're not constituent parts. They're pieces of stuff, and they're reabsorbed as pieces, but they're not fundamental character. They're pieces. Alright, you detail theory, but you don't explain how observation destroys the phenomenon of your theory. So I had a conversation in Tiny Chat with him about this observation thing. Observation's a silly word to use in the first place, because we can't observe any of this shit. We certainly can't passively observe a photon or an electron in any way whatsoever, benignly observe. We can only interact, and clearly the fact that interaction would destroy the phenomenon is just a fact of that you're going to destroy its trajectory, and in doing so it will no longer go where it was going, and therefore won't interact with the slit material, and therefore will not be diffracted, and therefore will not end up where it's supposed to. How do you explain the fact that observation destroys your wave-like interference? It's not my wave-like interference. It's my argument that it's a filtered result. And it's only wave-like in that it's a filtered result. All filtered results have certain common constituent pattern to them. The fact that it's a pattern does not mean it's a wave. The fact that it's similar to a wave pattern is just a digitized pattern, right? It's an analog. Analog goes in and kind of a digital comes out. Many things do that without the requirement of some wave creation. But obviously there's fundamentally something digital about the way a wave is. You know, it has a 0, a 1, and 0, and negative, a 1. You know, these are definitely, it has points that could be called digital points, like peak amplitudes and frequency. Yeah, how does this glass thing work if we are dealing with discrete particles? I explained in the video. I don't know why you can't get it. It works because it's a signature on the glass. The glass changes. That's why the photons behave differently, is because the glass wears a signature of its composition. If you make the glass thicker, the surface of the glass has a different atomic structure. That's all. It vibrates at a different rate. The atoms are positioned differently. Take either one of those as the answer. Both of them, I think, are an explanation. Also, the experiment results you looked at hardly supports your theory. Well, I disagree. Surely you'd expect a very clear interference pattern when one slit can be clearly seen. Well, clearly, if you look at their experiment, obviously the light or the aperture they're using isn't creating a very good two-slit experiment result anyway, right? I mean, they're blobs of light. There's no clear zeros, so they are obviously not focused their experiment very well. I've seen much better interference patterns. So their two-slit experiment is already creating a dirty, even without the barrier, It's a dirty two-slit experiment to start with. So why would you expect a clearer pattern with one slit open when the two slits open result was dirty? You'd expect it to be dirty, noisy, to be not a very good picture, not very well focused. So I'm arguing that with one slit open you can clearly see the creation of a filtered result. There's clearly the trailing blips that have clear empty space between them, and then there's clearly difference in intensity blips in the which should be just a wave, just a single clear even wave, and it's clearly got blotches in it. So I'm sorry, you're wrong. This is clear exposition of your view. I think it's an interesting idea. However, I'd appreciate if you would, this is the same asshole, take Hoffley's point and explain how measurement destroys the interference pattern. Well, again, measurement can't be done passively. If you're thinking measurement can be done passively, I just think you don't understand what's being talked about here at all. There's nothing smaller than photons. You can't throw something smaller than a photon at a photon and bounce it back. We see things because we bounce tiny, tiny, tiny things at huge things. So something that could be made out of a gazillion, trillion, zillion photons, and we throw 5 photons on it, and we can see it based on the reflection. So we're barely influencing something that's gigantic. It's like throwing a fucking grain of sand at the Earth. You can do that all day without changing the orbit of the Earth. But you can't throw a moon at the Earth and then say you didn't interfere with the Earth. That would be silly. And these are more like the relationship of photon to electron is probably something more like moon to Earth than light to human being. So anyway, so yes, obviously measurement is not what's happening. It's clearly interference. That's just it's influence that's destroying the interference pattern. And clearly there's also this insane lie that got started that somehow you could turn off the recording device, leave the detector on, and not record it, and somehow the pattern returns. That's just made up as far as I can tell. There's no evidence of that. I've seen no experiment that demonstrates that. It's pretty much just a lie. So I'm not going to explain a lie. Alright, Inmendham, seriously dude, why do you keep spelling matter that way? Well, why does it matter? Oh, you're the spelling police. My mistake. You're an idiot. Who cares? So anyway, yeah, it's not exactly the video I was looking to make, but close enough. Yeah, tired. So yeah, there's lots of this stuff to go through. I mean, this is just preliminary stuff work I'm doing, but I'm just trying to think of the different kinds of mechanical mechanisms that can explain the shape of matter, that would explain its properties, the pieces of matter and its properties. But what we define as a piece is where things start to get tricky, and because now they're using so much technology that it's hard to be sure what you're seeing is something real or it's just an artifact of the technology. You know, the technology is synthesizing the reality rather than in any way observing it. But anyway, yeah, so until next time and such.